Okay. Hello. We are going to look at tree traversals. First of all, what is traversal? A traversal is a systematic way to go through all the nodes of a tree. So, okay. So, a systematic way to go through all the nodes of a tree. And in this lecture, we'll look at binary tree traversals. Okay. So, if at all these traversals can be applied to non-binary trees, I will just state that. But as examples, etc., we will look at binary tree traversals. Okay, fine. So we will see three kinds of tree traversals. One is called as pre-order tree traversal, post-order tree traversal, and in-order tree traversals. These are the three traversals we are going to look at. First, pre-order traversals. I will give you an example. I'll show you an example tree of integers, and we will see how the pre-order traversal is going to go through all the nodes of that particular tree. Fine, good. Let me first draw the tree. So this is the example tree we are having. And first, what is pre-order traversal? First of all, as you can see, it's a binary tree. And in a pre-order traversal, the first thing you will see is first you will visit a particular node, and then you're going to look at its left child and then right child. Okay, so let me rephrase it. In a pre-order traversal, we are going to first look at the current node, we are going to look at the node and then look at its left subtree. After that, look at its right subtree. In other words, in a pre-order traversal, I am going to first see the value in that particular node, then I traverse the left subtree and then I traverse the right subtree. Fine. This is what. Okay. So let's start from the root node, and I'm going to, when I check the value in a node, I'm going to print its value. Okay. So that's how I'm going to do it. So I'm going to start from this root node, and we start printing the nodes when we visit that particular node. It's called as visit when I check up the value in that particular node. Okay, the term we use is visit. Okay, so first I visit a particular node. So I start from the root, so I visit the root first. Okay, so when I visit the root first, I'm going to print the root value. Okay, once I visit the root, so this is my first, I visit from, start my visit from here. I visit this node, so that means I see the, check the value in that node, and I'm going to, so when I check, I'm going to print that value, so that is 20. Next I visit its left subtree, so I come here. Okay, so first I turn left. This is my first step when I visit. After I visit a node, I'm going to turn left. So now I have to visit this subtree and then I visit this subtree. Okay, right. So again, when I visit this subtree, I'm going to first go visit the root of this subtree, that is this node. So what should I print next? I should print 10, right? Okay, so I print 10 next because I'm going to visit this node. Then again, I visit the subtree here, right? So this is again my, this is again the, again this is the first thing I do here, right? Okay, I visit this subtree and then I visit this subtree. Okay, so when I visit the subtree, I'm going to first visit the node there, its root. So I print 70. Good. Then what do? I visit its subtree here. Okay, and which means I have to print 100. Good. So now I have visited. So okay, once I have visited this entire subtree, what is it I have to do? So let me just let me have one more node here, and let me call it. Okay. So once I have, so this, once I visit this node and I have visited the left subtree, what is it I need to do? I have finished my entire left subtree, then I go to my right subtree. So this is the second thing I do here. Okay. So I visit this second subtree. Now when I visit this subtree, I'm going to print 40, right? Okay. So now I have visited the entire left subtree of this node. This is done. So what is it next thing I do? I have to visit this subtree. So I print the root there, right? I'm going to visit here. I come there, I print 50, then I turn left here, right? This is the first thing I have to do after I visit it, right? So I now go there and I print 90. Then I see that, okay, this is over, right? For this tree, this subtree, this part is over, its left subtree is over. So I go to its right part and I print 1. Okay. Now this entire thing is over. This entire subtree is over, right? So this was second thing coming here. This entire subtree is over. So I go here. I have done the entire subtree of this. Entire subtree of its left child, right? This entire subtree is done. So I move to its right subtree. Okay. So I'm going to print 30. Then I go to its left subtree and I print 15. So this is how I'm going to visit each and every node, right? Okay, so I'm going to, next thing what we will do is the following. I will write a function to do this pre-order traversal, and then we'll go through another example, and we're going to look at another example and see how the function is going to work in that example. Fine, right? Let's do that. Okay, the function is going to be called pre-order traversal, and it's going to start from a root node. Okay, it's going to start from a root node, and first thing when I visit the tree, what is it I need to do? I'm going to print the value there, right? So I'm going to print that. Once I have printed the value there, okay. So how to see it is, you have to see it recursively, fine. As we told, most of the tree algorithms are going to be taught recursively. Once I have printed the value at the root of that node, what is it I have to do? I have to visit the left subtree, right? So I have to do a pre-order traversal on the left subtree, right? So that's how you have to think recursively. Now when I go, if I have to do a pre-order traversal on a node, the idea is that I print the value at that node and then I recursively do a pre-order traversal on its left subtree followed by a pre-order traversal on the right subtree. So it's simple to write it. So I'm going to have a recursive step here. It says T left and then T right. Okay, this much is fine. This is a recursive function. Is something missing in this recursive function? What is missing in this recursive function? What is missing is, in the, we have told a recursive function should satisfy, what is the first property a recursive function has to satisfy? It should have a base case. What's the base case here? I haven't written a base case. What should ideally be the base case here? The base case is the leaf node. We're going to work with the leaf node, and that's where there is no recursive step after the leaf node. So what is a leaf node? So you come up to a node and it does not have a left or right tree, subtree, then that's kind of that's the base case, right? So you have to, now to implement the base case, you will have to write the following. You have to say that, see, does it make sense to do a pre-order traversal on the left if there is no left node, or if there's no left child, if the left T dot left, if it's null, does it make sense to go left? It does not make sense. So what should I write here? If T left not equal to null, only then you do this thing. Similarly, T left, T right not equal to null, only then you do this, right? Okay, good. This is our function. Okay, but we can just simplify this. I mean, this pre-order traversal looks good, and I mean this is correct. But we'll just slightly modify it so that it looks even better, right? What I'm going to do is the following. I'm going to make this. I'm going to add an extra line in the beginning of this. And I'm going to write the following. I'm going to write if I'm going to write that if you pass a null pointer, I'm going to just return because we are not going to proceed further. Okay, and this is going to be my base case, right? That's what this is how I'm going to simplify this the code. I mean, there's nothing. Both code are the same. It works same, but this is going to look better. That's all. Okay. So this is going to be my function. It's basically saying that, okay, what happens if t dot left was null? That means if I reach a point where I reach a node where it does not have a left child, it's going to call pre-order with a null pointer. And then it comes recursively to this function and it says, okay, t is equal to null, and it just returns without printing anything. There's no problem with that. So it's going to return here with, so if I call pre-order null here, it just goes there and comes back without doing anything. Same thing with write. So that's one simplification I just did. Okay. So this is my pre-order traversal function. Now once I have this function, what I can do is that I'm going to write, Let me take another tree example and then work it out. Okay, let's see the traversal. Okay. Okay, this is my tree, and what we are going to do is the following. I'm going to number the nodes in the order in which it's going to traverse. Okay, let's do that. What is first node it's going to visit? First node. So this is the visit statement. This is the visit statement, and this is the base case now. The base case is when you get a null pointer, and these are my recursive steps. Every traversal will have these three parts. Every tree traversal is going to have these three parts. So visit here, when I visit a node, I'm printing a value here, but it could be something else in a visit. It could be maybe I add up the values which I visit. I look at the value and I'm going to maybe sum it up. It's sometimes used, for example, consider this problem. As we said, your directories, folders or directories in your computer, they are going to be stored in a tree fashion. Okay, we are going to use a tree to store the directory structure, right? This is something, you know, it looks like a tree. The directory structure looks like a tree. And now I ask the following question. This is something you all might have done. You go to a directory and you check whether what is the size of this directory, how much bytes does this directory take. So this, how do you do that? You have to do a recursive traversal over, you have to traverse all the folders in that directory, right? Because inside a directory there can be other directories, so you have to go there. Inside that directory you can have other directory, you have to go there. So you have to go into each and every directory inside a directory and then calculate the size of each of those folders, right? Each folders might have other files whose values you will have to calculate. So the visit is, once you go to a directory, you want to calculate the size of that particular, the files in that particular folder, and recursively you are going to traverse inside the folders inside that particular folder, right? This is so that's one way you can do a pre-order traversal on a directory structure and return its size. Okay, so in that case, the idea of visit was to calculate the size of the directory, and but here in our example, I'm just going to print, because this print in an abstract sense, you can view this print as any operation you would like to have done on the value, right? It could have been anything else. Okay, so now what we are going to do is that I'm going to do a visit. I'm going to write the numbering on this tree in the order in which it's going to be visited. What is the first node which will be visited? The first node it's going to be visited is this root node, and therefore it's going to be numbered 1. What is the second node which is going to be visited? The second node which is going to be visited is its left subtree, right? So you come here, you're going to visit the first, you are in root, you go to the you print the value there, so that's your visit, you're going to write 1 there. Then you go to its left subtree, you're going to do a pre-order on its left subtree. So pre-order t dot left. What is t dot left? This pointer, right? This node is t dot left. You pass t dot left to pre-order. So you're coming here, and t dot left comes there, and you print the value of at that node. That's you're going to visit this node. So this is second. What will be the third? Right? Because you're going to visit its, you come here and you're going to visit its left child. Right? Fourth, fifth. Let's assume that I am visiting this function with this node. Okay, I'm going to name this node Let me call it T0. Okay. So I call this function pre-order with T0. What happens? I come here and I print T0's value, that is 4. Good. Come down, pre-order T0's left. I go there, right? And I'm going to name this T1. So T0 left is T1. So pre-order T1. So I come in pre-order function with T1. I come down, printf T1 value. What happens? T1 value is 5 and 5 is printed. I come down and then goes T1's left. What is T1's left? It's null, right? So I come here with null, right? So pre-order null, and it says if T is equal to null. So if it's null, I return. So I come back here with a return here. Then I come here down and I call pre-order of right of what? Pre-order of T1's right, because this is right now I'm in pre-order of T1. So I call pre-order of T1's right, again that's null. Come here, it's null, so it's returned. Now I am here again in T1 function, right? So I am in pre-order of T1 here, and I am now returning from there. So once I return from here, where do I come? I reach here, this point in where? In T0, pre-order of T0, I reached this one, that is I finished calling pre-order of T1, and now I need to call this function with what? Pre-order of T0 of right. So let me, if I call this T2, I have to call this pre-order of T2, right? So that will be the next thing. So I am now coming here, pre-order of T2, which is here, and I print T2's value. This is now, I'm going to call it 6. Okay. Now again, the same argument repeats, that pre-order of T2 is left null, so nothing happens. T2 right null, nothing happens. Now this entire subtree is now done. So what happens? It's now, okay. So this, okay, all this started from this 3's left subchild. Now, so it has come down here after doing pre-order of T's left child, right? So now it's going to call pre-order of this nodes. Let me call it T dash. So T dash left is done. So now pre-order of T dash is right, and that's null. So nothing happens, right? Nothing to be printed, and then everything is done. And now we come here again. Now let me call it T double dash, and its left is now done. T double dash left is done. So now we go to T double dash right. So I have to now come here. So I'm going to come there, and I do the same. I follow the same procedure. 7 here, right? That will be the 7th node visited. 8th node, its child, left child, and then 8th, there's no left child, so that's null, so nothing happens. And then 8th right child, so that's going to be 9. Now this entire thing is done. So 7's right child, null, nothing happens. So now the entire subtree of 2 or T double dash is done. So we now go to the root, right? So the roots, now entire left tree is done. So roots right tree is called. So this is going to be 10, and this is 11, this is 12, this is 13, 14, 15, right? So I hope you understand how pre-order tree traversal is done. So now what can come up as a question, right? So the standard question is, if I give you a tree, you should be able to number the order in which pre-order traversal is going to take place. Okay, so that can be a question I can ask. Or I can give you a tree and you need to print the sequence of numbers in a tree order fashion, right? So that's, you have to visit the nodes in the tree in a tree order fashion. That's another question I can ask. So these are things, standard questions of tree traversal. Okay, now we have done pre-order traversal. We proceed further to another kind of traversal called as post-order traversal. Okay, so in this pre-order, so let me explain post-order through pre-order. So in pre-order, the first thing we visit is the the first thing we do is when I go to a node, first thing we do is I visit the node. That is, I print the value or I do something with the value of that node. That is the first thing we do here, right? Now, and then I do recursively. I do its left subtree. I traverse its left subtree, and after that I recursively travel the right subtree. This is how I do in a pre-order traversal. What is post order? What is pre here? Pre is this visit. The visit of that particular node is before its children's ancestors, before traversing the ancestors. That is why it's called as pre. So what is post means? So post is going to be visiting the node after traversing the children, okay, or after traversing its ancestors. So let me just modify this function to do a post order traversal. This is post order. Did you notice what is the difference? The visit happens after the recursive calls. Okay, now, right, so the visit happens after the recursive calls. Can you do a traversal of this tree and tell me and print the values of the node in a post order traversal? Let's do that. So we are going to traverse this node, this tree, sorry, we are going to traverse this tree and print the values of the values in this tree in a post order fashion. Okay. So post order, I come to the root node, right? So it's going to start with the post order is going to be called with this root node, which has 1. Am I going to print 1? No, we are not going to print 1 because first thing you have to do is you have to call a post order left. Okay, so I do a post order left. I come here. Am I going to print that? So I am now inside this post order function with this node, right? So with T0. So I am with the T0 node. Okay. Now, am I going to print that again? No. I'm going to call its left. So I'm now here in T1. Again, so I'm inside post order with T1. I'm not going to print. I'm going to call its child, left child, T2. Again, am I going to call that, print that? No. I'm going to call its left child, T3. Now we are in kind of the base case. So I am inside T3. It's null. It's not null. So I come here, post order left. I go left. What is left? It's null. So I am now coming here with the null pointer, and it's going to return with doing nothing. So I now T3. So I am in post order T3, and I am done calling its left child. Now I am going to call its right child. So I call post order T3 dot right, and again that's also null. So I'm done here, and now I have reached here. Now I have reached the printf. So I'm going to print 5. Okay, so it's going to be 5. I print first. Okay, once 5 is done, so I am done with printing T3. What happens there? Then I return here. So now I have finished T2's. So I am now in post order with T2 here, and I have finished post order T2 of left because I finished T3, right? Now I come here. Now I'm going to call T2 of right. What happens? I come here, T2 of right. So let me just name it T4. Okay, let me just name it T4. I am in T4, post order T4 of left, it's null, nothing happens. T4 of right, null, nothing happens. Print the value of T4. So what is it? 6. Okay. So 5, 6 done. Next thing, once these two are done, so post order of, so what, so if I have finished T3 and if I finish T4, what, where am I now? So I am basically, I am in T2, so I have finished, I am in T2, I have finished this T2 of left, I have finished, I am finished T2 of right, and I am here. I have to print T2 value, 4. Okay. Next thing I have to do is, I have to print, I am now done with the entire thing. I go to this node and I have to traverse its right, but there is no right, so it's null. So once its right is done, I print the value there, 3. So I'm done here. Now I move. So I am in T0s. I am now in post order T0. I'm here and I finished the post order T0 dot left. I have finished the entire thing, and now I move to post order T0 of right. So I come here. I'm going to print. I come to this node, right, 7. So I go to its left, this thing, and then I go to its left, which is null, so nothing happens. Come back here and I go to its right. So now I and its left and right child are null and nothing happens, and I print the value there, 9. And since 8's left and right are done, I print the value 8. So now I go to, so I finish the entire left child of 7, left branch ancestors of 7. I go to the right ancestors of 7, there's nothing, so it's null, and hence that part is also done. So I now print the value 7. I visit that node. So now the entire left ancestors and right ancestors of 2, or the node T0, is done. Okay, so once these both are done, so both left and right are done, I am supposed to print the value. So I print 2. Now this entire left tree of root is done. I go to the right ancestors of 1. So I go to 10, and then I take its left, 11's left, 12, and 12's left and right both are null, so I print 12. I go back here, take 11's right, nothing, so both 12 and 11's right are done, so I print 11. This entire left tree of 10 is done. So I move to the right tree of 10, I come to 13, I go to 14. It does not have any children, so I print 14. It's done. I come here back and then I go its right, so I print 15. 15 does not have a left or right child. So once both left and right are done, I visit this node, so I print 13. So now left and right of 10 is done, so I print 10. Finally, both the root nodes left and right, entire thing is done, so I print 1. Okay, this is a post order traversal. Post order traversal. In a post order traversal, you're going to visit the left child. I'm going to summarize. So in a post order traversal, I'm going to visit the left child, the left ancestors, and then I visit the right ancestors, and then I print the value of mine. I visit the node. Okay, that's post order. And what was pre order? Recollect. I first visit the node, so I print the value of the node, then I visit the left child, left ancestors, and then I visit the right ancestors. That was pre order. Okay, so in this tree, what was the pre-order? Just recollect, the pre-order was basically this numbering 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 up to 15. Okay, so this is post order. Okay, and pre-order was was 1, 2, 3, 4. In that order, because that's how we printed the nodes in this order, right? Few things. I give you post order traversal and I ask you, I give you just some numbers, sequence of numbers, and I tell you that it's a post order traversal of a tree. Which is the value of the root? The root in a post order traversal, did you see? Which value is printed the last in a post order traversal? It's the root, because its left and right has to be finished and then it's printed, right? So where is the value of root in a post order traversal? It's here. It's the last. Where is the value of root node in a pre-order traversal? It's the first node, because I start visiting from here, I print the value there, then I visit children, right? So the root in a post order is the last value, and in the pre-order it's the first value.